All right, thank you so much for watching. This is Sichamba Jacob. Please remember to share the video. Okay, so this is Laplace. So Laplace is a word or the name that came from a French mathematician. Okay, this French mathematician came up with an idea of converting complicated ODE, some ODE. So when we say ODE, we are simply talking about ordinary differential equations. So this person discovered that there were some ordinary differential equations which were complicated. So he said we must convert them to a new function. So you can see this is a function which is being converted to a new function, this one. So this guy discovered a formula which we must be using. Okay, this is a formula over here. Very simple formula to understand. Okay, so here must be e power negative st multiplied by some function, any given function, and then here dt. So just like this. So this is how this person discovered, or this is a formula that he came up with, which may be working out, or will be working, not really may, but should be working out whenever we want to convert some complicated or deep E and work them out. Okay, so now listen. Let's do an example. This example right here, and see if we are able to catch the concept. So let's find the Laplace of this. This is an example I can give out. But before I give you this, or before I solve this example for you, let me just give you a little bit of some basics that you need to understand before, okay? Some integral basics that you need to understand before we answer this, okay? All right, so this is one of the basic integral that we need to understand before we do the example that we're supposed to do. So when they say integrate e to the power x, some of you struggle a lot. So for this one, you just say the answer is e to the power x right here, and you even say plus c. You see, this is the answer. Okay, whenever you've been given e to the power x, just know this, that it's the answer. The answer, the same thing that is inside, must be your answer. Okay, let's do another example which we need to know before we answer before we do the actual example that we need to do. Okay, so this is another example. So for us to be able to integrate this, you see there is a 2 here. There are some things that we need to do. We need to do the method that is called U substitution method, where we shall say let whatever power is here be equal to our u be equal to the power which is here. And then after doing that, we find the du dx, meaning we differentiate this with respect to x. So this will just give us a 2. When we find the derivative of this, it will just be a 2. So once we find that derivative, we can now make dx subject of the formula. Okay, so what I mean by saying dx subject of the formula, we shall just cross multiply. So it will be like this, you see, like that. And then we divide by 2 because we want to make this subject of the formula. So we shall remain with it, dx is equal to du over a 2. So this dx, which is right here, is equal to du over 2. I mean, du over 2, yes, du over 2, just like that. So the most important things that we need from this is this and this. So we need dx over du, du equal to du over a 2. We also need the u. U is equal to 2x, this u right here. So these are the things that we need. Now, when we get these things, look at how we do it. We are going to substitute. So this u, we know that u is, this 2x is equal to u. So we shall say e power u. And where there is a dx, we are going to substitute this. So it will look like this. You see the way it looks? So now from this stage, we can even factor out a 2. We shall remain with this. Hopefully you're able to see. So now, remember, I said the integral over this. We just said this same thing, is the answer, isn't it? This is what we said in example A. So now, if you're able to see nicely, this one is just alone here. So the integral of what is here will just be the same thing that is right there. So 1 over 2 e power u, which would definitely give us what? 1 over 2e power 2x, because our u is 2x. We even say plus c, like this. So these are some of the basics that which I wanted you guys to understand before we do an example. So now let's go back to an example, the actual example which we need to do. So our actual example, we need to find the Laplace, not to integrate, but to find the Laplace. So look at this. Laplace of what? Of e, this is e actually, e power at. Okay? So we're trying to find the Laplace of this. And of course, we know that the formula for Laplace must look like this. This is how the formula looks. Hopefully, you remember this formula. This is the formula. I showed you this formula, okay? So we shall say f of s is equal to the integral from 0 to infinity e power negative st multiplied by the function here. So we are going to put this function e power at and dt there, okay? So we simplify it further, 0 to infinity e. Here we can use the laws of indices. Okay, hopefully you've seen same bases, you add the powers, and this is what I've done. So from this stage, we can factor out, t is common, there's t here and there's t, we can factor it out together with the negative sign, and we shall remain with s minus a dt, like that, okay? So now, at this point, this is where we need to use the idea of example number B. The example number B that I gave you, this thing will be treated as a constant, the way we treated 2, okay? So we are respecting t. So all this power here, except the negative t. Actually, negative and s minus a will be treated as what? The constant. So let me copy up here and see how it is going to look like. So what we have is a negative, integral from 0 to infinity of e power negative t s minus a and dt there, okay? So just keep on following, you will understand. So the example that I gave you, when we integrate this with respect to t, we shall have a negative 1 over s a e power negative t s minus a, and the limits 0 will be here, the infinity there, okay? So just follow the idea that I gave you in example number B, example B. You integrate this, the answer will look like this, and then you put the limits just like that. So now from this stage, when we substitute the limits, the upper limit, okay, look at what we're going to get. So it will be e power negative infinity. When we substitute infinity here, all this thing will be infinity plus this negative. So it will be negative infinity right here. And then we say minus. When we substitute a 0 here, all the power here will tend to be a 0. It will be a 0, okay? So that's what we have, of which this whole thing will maintain this side, and then this e power negative infinity, because of the negative, the answer here will be a 0. And here, because of the 0 power 0, the answer will be a 1, which will definitely give us a 1 over s minus a. This is our solution. When we multiply this by this, it will give us a 0. Negative and negative, positive, this by 1, it will give us this stuff. This is how we are supposed to use Laplace for the example which we were given. Thank you so much for watching. Please remember to follow and share the video. This has been Sichamba Jacob.